First problem, find the Mellin transform of e power minus x. So we know that Mellin transformation of f of x, which is equal to integral 0 to infinite x power p minus 1 f of x dx. Put f of x is equal to e power minus x. Therefore, Mellin transformation of e power minus x, which is equal to integral 0 to infinite x power p minus 1 e power minus x dx. That is equation number 1. We know that gamma function, gamma n, which is equal to integral 0 to infinite x power n minus 1 e power minus x dx. So using this gamma function idea in equation number 1, so Mellin transformation of e power minus x, which is equal to integral 0 to infinite x power p minus 1 e power minus x dx. So here instead of n you are having p, that is gamma p. Right? Next problem. Find the Mellin transform of sin x. So Mellin transform of f of x, which is equal to integral 0 to infinite x power p minus 1 f of x dx. Put f of x is equal to sin x. So Mellin transformation of sin x, which is equal to integral 0 to infinite x power p minus 1 sin x dx. That is equation number 1. We know that e power minus ax sin bx dx. This is the formula, standard formula, which is equal to e power minus ax by a square plus b square into minus a sin bx minus b cos bx. So replacing a by t and b by p and taking the limit 0 to infinite, this becomes integral 0 to infinite e power replacing a by t minus tx and sin b by small p, right, sin px dx, which is equal to e power minus tx by t square plus p square minus t sin px minus p cos px. So limit lower limit 0, upper limit infinite. Applying the upper limit e power minus infinite, instead of x we are putting infinite, so e power minus infinite t square plus p square minus t sin infinite minus p cos infinite minus the lower limit 0 e power minus 0 t square by divided by t square plus p square minus t sin 0 minus p cos 0. We know e power minus infinite equal to 0. 0 into something 0. So first term completely 0. Second term e power minus 0 1. Right? Sin 0 0. Cos 0 1. So this becomes 0 minus 1 by t square plus p square. Sin 0 0. So total term 0 minus p cos 0. Cos 0 1. So that is p divided by minus into minus plus p divided by t square plus p square. This can be written as p divided by, so I am factorizing t square plus p square, so this can be written as t plus ip into t minus ip, right? That is equation number 1. Now using the partial fraction method, we are splitting into two terms, right? So that is left hand side of the equation number 2. So we are taking p by t plus ip into t minus ip, which can be written as a by t plus ip plus b by t minus ip. That is equation number 3 by partial fraction. Multiplying both sides of 3 by t plus ip into t minus ip. So left hand side t plus ip into t minus ip in numerator and denominator get cancelled. So you will get p, which is equal to a into t minus ip, t plus ip get cancelled. So you will get t minus ip in the numerator. Plus in the second term t minus ip get cancelled, you will get t plus ip in the numerator. That is a star number, instead of number we are putting star mark, that equation, right? So put t is equal to ip in the star equation. So p, which is equal to a into ip minus ip plus b into ip plus ip, right? T minus ip, t plus ip. So replacing t by ip. So p, which is equal to a into 0, so that term 0, so 2 ip into b, right? P is equal to, so p get cancelled, so you will get 1 equal to 2 ib, b is equal to 1 by 2i. Similarly, put t is equal to minus ip in the star equation, so you will get p, which is equal to a minus ip plus b minus ip plus ip. So b into 0 0, so minus 2 ip, which is equal to p, right? So p get cancelled, therefore 1 is equal to minus 2 ia, therefore a is equal to minus 2 by I. So we are putting the value of a and b in equation number 3. So p by t plus ip into t minus ib, which is equal to a by minus 2 by 2i, 1 by minus 1 by 2i by t plus ip, plus b 1 by 2i by t minus ip. So 1 by 2i is common, take it outside. 1 by t plus ip plus 1 by t minus ip, right? So that is equal to 1 by 2i. So taking the t plus ip to the numerator, t plus ip whole power minus 1 plus t minus ip whole power minus 1. That is equation number 4. So using 4 into integral 0 to infinity t power minus tx sin px dx, which is equal to 1 by 2i minus t plus ip whole power minus 1 plus t minus ip whole power minus 1. Now we are going to differentiate both sides by with respect to t, right? So d by dt of integral 0 to infinite e power minus tx sin px dx, which is equal to d by dt of 1 by 2i minus t plus ip whole power minus 1 plus t minus ip whole power minus 1. So without loss in generality, we are taking the differentiation inside the integration. Integral 0 to infinite d by dt of e power minus tx sin px dx, which is equal to 1 by 2i. So d by dt of first term minus t plus ip power minus 1 plus d by dt of the second term t minus ip whole power minus 1. So derivative of e power minus tx, right? We know that is e power minus ax, differentiation of e power minus ax, which is equal to minus a into e power minus ax, right? Similarly, we are having e power minus tx. So minus e power minus tx into x. Here differentiation with respect to t, right? So x is a constant. So minus integral 0 to infinite e power minus tx into x sin px dx, which is equal to 1 by 2i differentiation of t plus ip whole power minus 1. So already you are having minus. So minus 1 becomes, so we are using x power n formula, n into x power n minus 1. Here instead of x you are having t plus ip. So minus t plus ip whole power n minus 1, 1 minus 1 minus 1 minus 2. Similarly the second term minus t minus ip power minus 2. So that is equal to minus 1 by 2i, taking minus outside, minus 1 by 2i minus t plus ip whole power minus 2 plus t minus ip whole power minus 2. Again second differentiation with respect to t. So d by dt of integral 0 to infinite e power minus tx x into sin px dx, which is equal to differentiation of minus 1 by 2i minus t plus ip whole power minus 2 minus t minus ip whole power minus 2. So that is integral 0 to infinite d by dt of e power minus tx x into sin px dx, which is equal to minus 1 by 2i derivative of the first term minus t plus ip whole power minus 2 plus derivative of the second term t minus ip whole power minus 2. So again e power minus tx is minus e power minus tx into x, right? So x into x square, right? So you are having minus get cancel. So e power minus tx x square minus into sin px dx, which is equal to 1 by 2i, right? So minus minus t plus ip whole power minus 2, differentiation minus into minus plus 2 into t plus ip whole power minus 3, right? So already you are having a minus. Similarly for the second term minus 2 into t minus ip whole power minus 3. So 2 is common, take it outside. 1 by 2i minus also common, take it outside. Minus into minus plus, already you are having minus in the outside. So 1 by 2i into 2 minus t plus ip whole power minus 3 plus t minus ip whole power minus 3. Proceeding like this, after m minus 1 times differentiation, you will get, so minus plus is repeating, so right, so minus 1 plus 1 is repeating, right? So minus 1 power m minus 1, that is what we are writing. The first integration you are having minus outside, The second time you are integrating, you will get plus, and third time you are getting minus. So each and every time the minus is repeating, right? So one after another step. So that is what minus 1 power, how many times? M minus 1 times. M minus 1 integral 0 to infinite e power minus tx. So first time x, second time x square, m minus time x power m minus 1 into sin px dx, which is equal to, similarly here also the minus is repeating, so minus 1 power m minus 1, first term 1, second times you are having 2 by 2i, right? Third time 3 by 2i, fourth time 4 by 2i, repeatedly. So m minus 1 times m minus 1 by 2i. So minus 1 power m minus 1, so 2 into 3 into etc etc m minus 1 into 1 by 2i minus t minus t plus ip whole power. So first time you are having minus 2, then second time minus 3, and third time you will get 4, right? So m minus 1 time you will get m minus 1 plus 1, right? First time 2, first time means 2, 1 plus 1, second time means 2 plus 1, so third time means 3 plus 1, right? T plus ip power I am talking about. So m minus 1 time m minus 1 plus 1, so you will get m minus t plus ip whole power minus m plus t minus ip whole power minus m. So that is equal to minus 1 power m minus 1, 1 into 2 into 3 up to m minus 1 multiplying, that is m minus 1 factorial 1 by 2i minus t plus ip whole power minus m plus t minus ip whole power minus m. That is equation number 5. Now you consider 1 by 2i minus t plus ip whole power minus m plus t minus ip whole power minus m. So put t is equal to r cos theta and p is equal to r sin theta. So 1 by 2i minus t plus ip whole power minus m plus t minus ip whole power minus m, which is equal to 1 by 2i minus replacing t by r cos theta plus p by r sin theta. So r cos theta plus I sin theta whole power minus m plus r cos theta minus I sin r sin theta whole power minus m. So 1 by 2i, r is common, take it outside, r power minus m, because r is inside the power minus m. So when you are taking r power minus m into minus cos theta minus into minus cos theta plus I sin theta whole power minus m plus r power minus m cos theta minus I sin theta r power minus m. So taking r power minus m outside by 2i minus cos, so we are using De Moivre's theorem, right? Cos theta plus I sin theta whole power n, which is equal to cos n theta plus I sin n theta. So we are using that idea. So minus already outside, so cos minus m theta plus I sin minus m theta. Similarly in the second term plus cos minus m theta minus I sin minus m theta. So r power minus m by 2i minus cos minus m theta minus I sin minus m theta plus cos minus m theta plus I sin minus m theta, right? So that is equal to that minus I sin m theta, last term minus I sin m theta. So minus cos minus m theta plus cos minus m theta get cancelled, so you will get 2 times minus 2 times I sin minus m theta. We know sin of minus theta, which is equal to minus sin theta, right? So minus r power m, 2i get cancelled, minus sin m theta, right? So that is equal to minus into minus plus, therefore 1 by 2i minus t plus ip whole power minus m plus t minus ip whole power minus m is equal to r power minus m sin m theta. Since t is equal to r cos theta and p is equal to r sin theta, therefore r sin theta by r cos theta p by t, therefore r get cancelled, tan theta is equal to p by t, so theta is equal to tan inverse of p by t, because we have to replace m and theta in terms of p and t, right? Substitution method. So again we are squaring and adding both one, so r square cos square theta plus r square sin square theta, so t square plus p square, r square is common, so r square into cos square theta plus sin square theta, which is equal to t square plus p square, therefore r square, which is equal to t square plus p square, because cos square theta plus sin square theta 1, right? So r is equal to t square plus p square whole power 1 by 2. So r power minus 1 equal to t square plus p square whole power minus 1 by 2. So r power minus m, which is equal to, taking m power m on both sides, r power minus m is equal to t square plus p square minus m by 2. Right? We are going to replace that one. Right? The r 1 by 2i minus t plus ip whole power minus m plus t minus ip whole power minus m is equal to r power minus m sin m theta. So we are replacing r power minus m by t square plus p square minus m by 2, and sin theta is replaced by m into tan inverse of p by t. That is equation number 6. From 5 and 6, minus 1 power m minus 1 integral 0 to infinity e power minus tx x power m minus 1 sin px dx, which is equal to minus 1 power m minus 1 m minus 1 factorial. We are substituting from equation number 6, t square plus p square whole power minus m by 2 sin m tan inverse of p by t. Therefore, so we are cancelling minus 1 power m minus 1 on the left hand side and right hand side of the equality. So you will get integral 0 to infinite x power m minus 1 e power minus tx sin px dx, which is equal to m minus 1 factorial t square plus p square minus m by 2 sin m tan inverse of p by t. Replacing m by p and t by 0 and p by 1, we will get x power integral 0 to infinite x power m by p minus 1 e power, put t is equal to 0, minus 0 into x sin put p is equal to 1 into x dx, which is equal to p minus 1 factorial 0 square plus 1 square power minus p by 2 sin p tan inverse of 1 by 0. So integral 0 to infinite x power p minus 1 e power minus 0 sin x dx, which is equal to p minus 1 factorial 1 square minus p by 2 sin p equal to p minus 1 factorial 1 square whole power minus p by 2 sin p tan inverse of 1 by 0 is infinite. Right? So integral 0 to infinite x power p minus 1 sin x dx, which is equal to p minus 1 factorial minus 1 power minus p. So 1 power anything is 1, so we can leave it as it is. Sin p into tan inverse of infinite is pi by 2, p into pi by 2. So integral 0 to infinite x power p minus 1 sin x dx, which is equal to p minus 1 factorial sin p pi by 2. Right? That is question number 7. We know gamma n, which is equal to n minus 1 factorial. So replace n by p, gamma p, which is equal to p minus 1 factorial. So that is equation number 8. From 7 and 8, integral 0 to infinite x power p minus 1 sin x dx, which is equal to, replacing from 8, equation number 8, gamma p sin p pi by 2. Therefore, Mellin transformation of sin x, which is equal to gamma p sin p pi by 2. Thanks.